Hey guys, welcome to episode 5 of Coding Every Day until Codeforces GM. Let's start today off by finishing up War Strategy that we were not able to complete yesterday. So I think I was totally on the wrong track for this problem, just because of a combination of misreading the problem, misunderstanding how to actually move the soldiers. And I did some thinking yesterday and I came up with this idea of how do you optimally move these soldiers? You're never moving them how did we showcase last time where you're jumping one, so we have diamond, so that's home base. Let me just copy and paste these spaces over here. Okay, here we go. We're never moving it so initial, and then we move here, generate here, we move here, 0, and then generate. We're never moving it like this because this is just an inefficiency. We spend an extra day moving, and as we saw, as we moved, it increases the number of days it takes to actually move. Actually successfully fortify one extra base, it increases significantly based on days. So this is just not the best way to do it. Instead, what if we just let this cook for a few days? So to the right over here, it's 3 bases, or we can start from the left too. So let's just call this left and right. And this is day initial. Day 1, we just let this cook. Day 2, 3, and then on day 3, we can start moving. We move 3, and then this would regenerate, and then day 4, this would be 2, 1, 2. Day 5, it would be 1, 1, 1, 3, right? And so what this allows us to do, although it seems kind of counterproductive, it takes us 5 days to fill up 3 bases. What this allows us to do is it allows us to cook this middle term for the other side as well. So we don't have to repeat this process again because we're doing that while moving the right side. So the optimal way to, say we had an infinite amount of days, the minimum amount of time it takes us to fill both sides, to fill up the entire area, would be so we have to cook L minus 1 days because we were given 1 by initial, so it takes us 2 days to cook up 3. So it's L minus 1 plus the number of days it takes us to move, which is L. So this is the amount of time it takes to fill up the left side. But in order to fill up the right side, it would be, so say right side had 1 more box over here. What we would do is we would let this cook 1 more day, 1, 1, 1, 4, and then we could start moving them along, right? So it would be plus the maximum of L in R right plus r, because it's going to take us r days to actually move the to fill up the right side. So let's just check this real quick. So L is 3, R is 4, 2 plus 4 plus 4. So in theory, this should take us 10 days to fill up this whole thing. Let's just check. 6, 7, 8, 9, 10. 1, 1, 1, 1, 4. 1, 1, 1, 2, 3, 2, 1, 3, and 1, 1, 1, 2, 1, 1, 2, and 1, 1, 1, 2, or let's erase this. This is 3, this is 4, 1, 1, 1, 1. So it'll take us 10 days to fill up an array length 8, where our initial is 1, 2, 3, 4. So yeah, this is the formula to find, given an infinite amount of days, what's the minimum amount of time it would take us to fortify the entire base. So how does that help us? That's because this isn't exactly, like, we need to add more bounds to this because we are given a number of days bound. So we can't really afford to stack up forever, right? I guess it's just, from what I'm thinking, we try to fill one side, we stack up until we can, and then we try to fill the other side. Now, here's a question. Do we always fill the shortest? Is it better for us to always fill the shorter side first or the longer side, or does it even matter? I don't think it matters. Yeah, I don't think it matters because what are the cases? Case 1, it's L is less than M, so it would just stack up and fill L. If L is greater than M, you would just fill L by default. Yeah, if L is less than M, you would fill L and then start filling R with the stacked up dudes. So yeah, I don't think it would matter. So how would that look in code? So we have our left and right. And we need to check like how many days are we allowed to cook? Because like here's the issue right now. If we're given this and we're only allowed m equals 2, then it's not just better for us to stack up, right? Like we would like stack one day and then move one day and then get an answer of 2. So that's the kind of issue right now. So how can we bound this equation by number of days? Or can we split it up somehow? Or maybe we can track bases fortified. No. Okay, we always want to fill one side before we fill the other. Okay, so given this equation here, if this is less than or equal to m, what does that mean? Then we can okay, so that means then we can fill all the bases. So here's what I'm thinking. We just start with an initial base, and then we add a base, check if we can fill it. If we can, we add another base. If we can, add another base. If we're out of bases to add, then we add it on the other side until like we hit the constraints of the question or of the inputs, right? So we basically we have to loop through until like some condition fails. So instead of tracking L and right as L and R as k minus 1 in minus k, we can track them as L equals 0, R equals 0. So this, instead of being the length of the bases, these are the number of bases fortified on each side. And then while true, if R is less than n minus k, or if L is less than k minus 1, so this checking, what is this checking? This is checking if the left side is full or not. This is checking if there are still boxes that we can add to the left side, if there's still bases for us to fill in the left side. And L plus R plus, or L plus L, it's L, if we're expanding to the left, so it'd be L plus 1 minus 1 plus max L plus 1 r plus r is less than or equal to m. Okay, so this is saying suppose we fill the left side. If we fill one more base on the left side, then the minimum amount of time it takes us to fill all the bases is less than or equal to the number of days given to us. So it's basically checking if we can add one more box or not. So this one checks if we have available boxes to the left, and this one checks if we have enough time to fill that available box. If we do, let's fill that available box. And then let's do the same for the right side. So it's the same thing, so we exchange out all the L's for R's, and then this is n minus k. R plus 1, wait, no. Is it R plus 1? Is it L? Instead of L plus 1, it'd be like this. It's R plus 1. But okay, these can already be simplified. Like these are the same. 1 plus 1 minus 1, like it's all like this. So basically the only thing that matters is like what is getting added in the maximum. And then, yes. And then our answer should just be print L plus R plus 1 at the end. Because that should be the number of fortified bases to the left plus number fortified to the right plus the initial base. Now, okay, we need to break this loop somehow because I put it in a while true. So can I use a for loop for okay, when does this loop break? If neither of these things happen, it breaks, which means if there's no more room to the left or right, or we don't have enough days to increment the left or right. So it's some sort of like else break. Like if elif. Does this work? Is this it? Okay, let's run this. Two, three, three, two, three, 6. Okay, this seems to be working. Let's submit this. War strategy. Wrong answer. Okay, what's going on? Jesus, what is this? 1,000 inputs. Expected 5, found 4. I can't even check this, bro. It doesn't give. Okay. So it's an edge case, right? What kind of edge case would my code be stuck in? Maybe if it's like. Huh. Okay, well, we gotta be close, because we pass 313 tests and we miss one. We miss by 1, so it's 1 move that's not correct. It has to be something wrong with this while loop here, right? Mm. What could it be? Is it like an edge? Like it's missing by 1? Hmm. Is it cause... Oh, it might be because if one side is longer than the other, like if R is significantly longer than, like, does this matter? Like if R is longer than L and then I add 1, still the max of both. Like, what if I set like one side to be guaranteed to be longer than, if the left is less than the right, then k equals n plus 1 minus k. So this basically should guarantee that the left side is always greater than the right side. So then if we do the left first, we will always have enough for the right. Else break. Does this still work? The original test cases? Two, three, three, 2, 3, 6. Okay, let's try this. No. Did we get further at least? No, it's worse. Hmm. What if it's order based? Like, theoretically, we should allow them to do either of these, right? We shouldn't. Either left or right. Like, do we? Okay, because I'm constraining it to go left, then right. Yeah, because if the right is possible, the left isn't tried. Yeah, if okay, so basically if I do else here, if the left is possible, the right is never tried, which is not good. We should try both. So we can add like a variable here, like tried equals false, tried equals true, and then true, and if not tried, break. So if it doesn't go through either of these, we break, and then we just print. I think this is close. Two, three, three, two, 3, 6. Okay, still same stuff. Okay. Okay. Now the question is, did this matter? What if I didn't have this? I just want to test real quick because a part of me thinks this doesn't matter. Yeah, okay. What the side, like, whether, because, okay, yeah, because if we're not doing the else statement and we allow them to increment to test each side, then it doesn't matter which side is bigger. It'll just do it. Alright, okay. I think that makes sense. I might, like, look into this a little more on my own just to, like, fully understand it. But I think we'll just leave this question here for now. Let's do an easier problem. We haven't done an 800 in a while. Like, I've been trying to up the difficulty each time, but you know, the last few days we've been doing some hard problems. So let's take an easy one, and then we can bump it up to like 1,000 question or something. It's something just not so wordy. You know, have a chill day. 791A, Bear, and Big Brother. Oh, by the way, I'm also trying to like do shorts now where I kind of just summarize like one of these questions that we figured out together. I've released 2 shorts based off like episode 1, but the recording quality was kind of low. I don't really know why. Maybe it's like I have to mess with my OBS settings, but yeah, so these 800 questions are great practice for the shorts. But yeah, let's do an 800. Rating 800. Maybe we can knock out 3 questions today. Let's check the time. It took me 30 minutes. Okay, if we can do this one fast, we'll have time for a 3rd question. Okay. Baron Lamac wants to become the largest of bears. Or at least larger than his... Oh, Bear Lamac, that's his name. Wants to become the largest of bears, or at least larger than his brother Bob. Right now they weigh A and B. It's guaranteed Lamac is smaller than or equal to brother. Lamac eats a lot. His weight is tripled after every year, while Bob is doubled every year. How many full years will Lamac become strictly heavier than Bob? Imagine. Okay, this is an implementation question. Implementation questions are always like fun because you don't really have to think, you just do. The only line of input contains 2 integers, weight of Lamac and weight of Bob. Print 1 integer denoting. Okay. Lamac Bob equals map int input dot split. And then for while Lamac is less than Bob, count years equals 0. Lamac years just equals 1. Times 2. Well, Lamac triples every year, so Lamac times 3 times years Bob times 2 times years. Okay, so Lemac equals Bob equals then years plus equals 1 print years. Although since year 1 like it is guaranteed is smaller than equal to specify. Yeah, okay. Should be right. 4 7 3. Okay, something's not right. Because I started at 1. Huh? Okay, well I can't start at 0. Years plus equals 1. It's this incrementation. Year 1 be 3. Okay, I think it's I start at 0. I increment first. And then does this handle it? I'm at 0. First year 3 Lamac is 12. 14 Bob is 14. After year 1. Wait, what? How's this output 2? It takes 2 years? So year 0 is this. Okay, who's first? Lamac is first, yeah, and Bob. So Lamac tripled after every year. Doubles every year. Is it to the power of? Year 1. Year 1, Lamac would be 12. And Bob would be 14. Year 2 should beat it, so there we go. No, this is wrong. So 3 squared is 9. 4 times 9 is 36. And 2 squared is 4. 9 times 4 is 36. They are equal. Okay. Equal. Equal. There we go. Wait. That's not it. Nine times 4. 4 times. Oh, what? First year. years. Dude, how am I struggling so much on an 800? First year, Lamac, Bob. Second year, what? Oh, okay, I understand. I'm like double incrementing. I don't. I need the incrementer, but okay. Okay. Yeah. I see. Yeah, because I was setting that equal to. I get it. Um, that should be the answer. Big Bear, Big Brother. Big Bear and Big Bear. Bear and Big Brother. Come on, Codeforces. There we go. Now let's do a harder question. You know what? Let's do 1,200. Can't always do these low-rated questions and farm daily problem solved. Hello? Okay. Chewbacca and number. At least the reading for this is short. 514A underscore Chewbacca and number. Rating 1200. Luke gave Chewbacca integer x. Chewbacca isn't good at numbers, but he loves inverting digits in them. Inverting digit t means replacing it with digit 9 minus t. Help Chewbacca transform the initial number x to the minimum possible positive number by inverting some possibly 0 digits. The decimal blah 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 shouldn't start with 0. The number Luke gave Chewbacca, and then the minimum possible number that Chewbacca can obtain after inverting some digits. Number shouldn't contain leading zeros. Okay, so okay, this is pretty easy. Just another implementation question, right? Num equals input int. Or it's probably better to process this as a string, right? So we can use it as an array. To print equals 0 for in num if int in is less than 9 minus n. To print plus equals n, else to print plus equals stir 9 minus int n. print to print. That felt pretty easy. Types plus equals for int inster. There we go. Okay. Okay. Chewbacca and number. This did not feel like a hard question at all. Wrong on test 4. Okay. Spoke too early, I guess. Participants output. Oh yeah, to look for leading zeros. 9 minus 9. So n is 9. 9 is less than 0. Okay, so if it's 0, what happens? Like, why did he print 9 here, not 0? As leading zeros. Okay. Shouldn't start with a 0. So what we can do is the smallest possible number. So if it's 1 digit, okay, so here's to the case where there is a leading 0. It's like 09. We're gonna loop through and remove all the zeros, I guess, from the front for n and to print or let's see. We can typecast it to int. That should remove it. We can now. How do we handle this case where it's like, so if print is if len num is 1, print num, else check if it still works for these. Now let's check for a case like 98 1. Let's check for a case of just 9. Okay. Wrong answer on 8. Expected this, found this. Again with the 9. So they just don't want 9 minus 9? This is a very poorly worded problem, I believe. Unless they, like talked about in the problem. Minimum possible positive number by inverting some digits shouldn't start with a 0. Okay, but 9 minus 9 is 0, bro. So I just add a check for if 0 do nothing. If or is it if it starts with 0 do nothing? If it starts with, or do one of these have a 9 in between? If it's like leading. For I in range len num if num I if I equals 0 and num I equals 9 to print plus elif what? But it still got rid of my 9. So it didn't go in here? Oh, string. Okay. Now the problem is they don't give me a test case where when 9 is in the middle of the problem, but whatever, I guess. fix it again if it messes up. Just hope it doesn't mess up. Test 28. Okay, there we go. Alright. That's going to be the end of this episode. We kept it under an hour, which is great. If you enjoyed it, please subscribe and like, and I'll see you tomorrow.